Good morning, children. Today we will see faces, edges, and vertices. Before starting this topic, I hope you have completed exercise 10.2 and you don't have any kind of problem whenever you solve this exercise. And now we will see faces, edges, and vertices. Means what is faces? Faces means the front side or the whatever we can look. Suppose you have a cube and this side means this line is called edges, and this front side, suppose this is a book, for example this book, and this is the edge of this book, this one is the edge of this book, and this is the front one is the edge. Similarly, this is also a edge, this is also a edge, and this one is a, this we can call it as a face, like this. Similarly, this is a face, and this is one is a edge of this book. Now, and the corners are called as a edges. Now we will see different types of shapes. Each of these solid is made up of polygonal region which are called its faces. These faces meet at edge, which are line segment, and the edges meet at vertices, which are points. Such solids are called polyhedrons. Suppose you are familiar with pyramid shape. So this front side is a faces, and this edges, these 1, 2, 3 edges. Within these 3 edges, that whatever that area, that is called a face, and these are called the edges, and this point, and this point are called the solids, vertices. And where vertices and edges which are line segment and edges meet at vertices, these edges meet at vertices which are points. Such solids are called as a polyhedrons. So these solids are called as a polyhedrons. Now these are also polyhedrons, but these are not polyhedrons because here is no face. This is a cone, this is a sphere, and this is a cylinder. Here are no edges, here is only one edge, but all sides are not edges, all sides are not connected to the edges. So here is no also point, only here is, we can see the point, here is no any point, here is no any points or edges. This is edge, but points are, these edges are not connected to points. Now this is a sphere, this is cone, and this is cylinder. I just mentioned it. So here is a curved surface, here is a cone has a lateral surface, and cylinder has also lateral surface. How are the polyhedron different from non-polyhedrons? Study these figures and you know 3 other types of common sides. So this is a base, this is a base, but here is no any kind of base. Now we will see the convex polyhedron. You will recall the concept of convex polygons. The idea of convex polyhedrons is similar. You recall the convex and concave. We have studied that in last semester, and you might remember it is in the chapter 3 or 4. So this is a convex polyhedrons, and these are not the convex polyhedron because it is inside. Here is a inside, here is outside everything. So these are the convex polyhedron, and these are the convex. So regular polyhedron. A polyhedron is said to be regular if its faces are made up of regular polygons. Suppose, and the same number of faces meet it at each vertex. Suppose, look at this figure. This is a polyhedron. This polyhedron is regular. Its faces are congruent. All faces are, means this face is congruent. This face is congruent. and behind space and front one space is also congruent. Vertices are formed by the same number of faces. Here are number of faces equal to number of vertices, means 1, 2, 3, 4, 5, 6, 7, 8. So 8 vertices and 8 faces are here. This polyhedron, we can imagine this is not a regular polyhedron because all sides are actually congruent, but the vertices are not formed by the same number of faces. So here are 1, 2, 3, 4, 5 faces, but 3 faces meet at but 4 faces meet at B. Here A, at the A there are 3 faces meeting, and at B there are 4 faces. So these figures are not, these 3 and 4 not equal. So we can say that this polyhedron is not a regular polyhedron. We say that a prism, now this is a prism, these are prism and these are pyramid. Suppose two important members of polyhedron, this is polyhedron family around prism and pyramids. We say that a prism is a polyhedron whose base and top are congruent. Base and top are congruent polygons, and whose other faces, that is lateral faces, are parallelogram in shape. On the other hand, a pyramid is a polyhedron. A pyramid is a polyhedron whose base is a polygon of any number of sides and whose lateral faces are triangles with a common vertex. If you join all the corners of a polygon to a point not in its plane, you get a model for pyramid. A prism or a pyramid is named after its base. Thus, a hexagonal prism has a hexagon at its base. A triangular pyramid has a triangle of it as its base. What then is a rectangular prism? What is square pyramid? Clearly, their bases are rectangle and square respectively. Now, you have to complete this table. Tabulate the number of faces, edges and vertices for the following polyhedrons. Here V stands for vertices. Here F means faces, V stands for vertices, E stands for edges, and F plus V. F plus V means faces plus vertices equal to E, and E plus 2. E plus 2 means edges plus 2. You have to complete this table. And this is actually Euler's formula, that is F plus V. F plus V, look here, F plus V equal to E plus 2, or F plus V minus E equal to 2. This relationship is called as a Euler's formula. That's why in the last table we have to calculate F plus V and E plus 2. Now this is your homework exercise 10.3, and you have to remember the formula, Euler's formula for any polyhedron. F plus V equal to E plus 2, or F plus V minus E equal to 2. F stands for faces, V stands for number of vertices, and E stands for edges. So I think you can solve this exercise, and if you have find any kind of problem, you can contact me. Thank you.